I hope my sound problem is fixed. Somebody just said in the chat there's no sound, but there should be sound. And somebody else said in the chat, do all compounds have to contain cations and anions? That's a really good question. This is going to sound like a really dumb answer, but all ionic compounds have cations and anions. There's another type of compound we're going to look at in the next section called molecular compounds. They do not have cations and anions. So it was a good question with a silly answer. All ionic compounds must have a cation and an anion. All right, on to the anions. The anions are deceptively easy because first thing you do is look at the name and try and find it in your data booklet in the polyatomic ion chart. I've had 50 students ask me this in the last week. Do or will we get that chart on a test or final or anything? The answer is always. It's in the lab. It will be printed for final exams. You can use it during your quizzes online. I mean, you will always have your data booklet. So anything you see on that data booklet, do not memorize. Okay, so let's look at these. And actually, I have them written down here. So I'm going to go back to my data booklet, and I'm going to look for these elements, these anions. All right, so back to my data booklet. I'm going to now go up to the second page in the data booklet. This is one of the better pages on the data booklet because I actually remember having to memorize all of these, and it's been so long, I've worked here so long that I don't memorize them anymore. I've completely forgotten, but that's okay because I have a list right here and you have a list. So I'm going to circle any element on my list. Just hold on one second, or any ion on my list. So I have thiocyanate, I have sulfate, I have hydroxide. Guys, hydroxide is one of the most important ones. This chemical is in a lot of bases. We haven't really talked about acids and bases yet, but we will towards the end of this course. And hydroxides are very, very basic. Now, there's another element that I don't see here. Chloride, I think that's what it was. It's not here. There's chlorate, there's chlorite, there's hypochlorite, but there's no chloride, which means that must be Cl from the periodic table. So let me write down my anions. Thiocyanate, not one that I use a whole lot. We do have it in the lab though. It's SCN1-. Sulfate, SO4 2-. Chloride, I'll do that one in a second, and hydroxide is down here. Now, chloride, not in my periodic table. Let me go back to my periodic table. I closed it, hold on. All right, sorry. So chloride is not here. It's not in my list of polyatomic ions anywhere. So that must mean chloride is talking about chlorine here. You'll notice there's no charge written for that, but that's normal because basically the way this works is all of these have 0. These are 1-, 2-, and 3-. And everything else you don't need to worry about. All right. Back to my notes. We're finally putting this all together. Okay, so chlorine goes written in here, Cl1-. Okay, now this is, for me, this is what I like. I think this is the easy part, but it can be challenging. What we need to do is put these cations and anions together so that they cancel each other, so that the positive and negative are neutral or cancel. So this is, I mean, I'm starting you off with one of the easiest ones. Potassium is +1, thiocyanate is 1-. Perfect match. +1, -1, they go together nice and even. All right, this one, the next three get a little more complicated. I have 2- and 1+. So that means I'll need 2 positives to cancel that out. So I get Ag2SO4. All right, next one, I have 2 positive and 1 minus. So in this case, I'll need 2 chlorines to balance that. So CuCl2. And then the last one is a little bit tricky. I have 2 positive and 1 negative. Watch what happens here though. So I have barium. Sorry, let me fix that. I have hydroxide, and I'm going to need 2 of them to balance that charge out. But there's a problem here. That 2 looks like it's just for the H, the hydrogen. I want to make sure that the 2 is for the whole polyatomic ion group. So I put a 2 there, and I'm done. That is how to write the formulas for the names. And that's 8 examples now. We did 4 yesterday and 4 today. So before I move into the last topic, does anyone have any questions on this?
Yes, Mr.
Yeah, ask, sure.
Copper and chloride.
Yes.
If we transfer chloride and put it oxygen, oxygen is already have 2 down, right?
Yeah. Okay, that's a good question. So guys, if you can't hear, the question was very good. What if we didn't have copper 2 chloride? What if it was copper 2 oxide? Well, I'll do this in purple on the bottom. So copper 2, oxygen is in the next group. It's in group 16, which means it has 2 or a charge of -2. Well, this is a perfect match. +2 and -2 cancel. So the formula for copper 2 oxide would be CuO. And you're kind of leading me into talking about that misconception again. A lot of people see copper 2 and think that I need 2 coppers. That has nothing to do with it. It's all about the charge. The 2 represents the charge on copper. All right, we're going to do more of this, by the way. I mean, this whole chapter is about naming and writing names, and we'll do lots more practice. But if there's no more questions, I'm going to move on to the last part of today. All right, so okay, we just did taking the name and writing the formula. Now what we're going to do is take the formula and write the name. My personal opinion, and this is coming from someone who found naming very difficult when I was younger, I find this to be harder. So going from the name to the formula is easy, because the name tells you the charge on the metal, the polyatomic ion name. You just go right to the data booklet. This is a little more challenging. So I want to explain how to do it. I want to show you 4 out of 8 examples, and then I'm going to give you guys the other ones to try yourself, and that's it. So here's the procedure. Step number 1, just like in the other topic, start with the metal. The metal is always on the left. It's the first thing you name or first element you write. So first write the metal name. Now here's the challenge. You can see basically 3 types of metals on the periodic table, or arguably 2 types. We have elements that just have the charge flat out listed, like zinc, silver, aluminum. These are elements that just have the charge listed. You can see right here with zinc, it's just 2. Zinc is zinc 2. Excuse me. We have other elements on the periodic table. I'm going to move to the bottom, that don't have anything written. And I don't really know why, but we won't get into that today. I guess the idea is anything in group 1 is +1, anything in group 2 is +2. These types of metals do not need Roman numerals. The reason they don't need Roman numerals is because they only have 1 charge. The only time we need Roman numerals is when there might be more than 1 charge. So you see this in the transition metals. Iron is a prime example. Iron likes to exist in compounds as iron 3 or iron 2. And depending on the iron you have a completely different chemical. Like, one could be used in food, you could eat it and it would be safe, and another would be completely poison. I mean, the difference between the charge on ions is huge and can completely change an experiment. So we use Roman numerals to tell the viewer, the reader, me, or lab instructor, whatever, what metal, specifically transition metal, we're talking about. And I'll kind of get into more detail here when I do some examples with you. Once you've looked up the metal and the charge on that metal, look up the nonmetal. You can start with the polyatomic ion table. If it's there, just write the name. Don't change anything. Never mess with the names on the polyatomic ion table. If it's not on the polyatomic ion table, it's probably just one element. So like Cl, Br, F, or I, or even O. We would change these names when we write them down. I don't have an answer why it's changed. I think it's to kind of explain that it's a name and it gives it flow. Like when I say, let's take the example I did on the other slide, calcium chloride. Well, I'm telling you that it's calcium and chlorine bonded together. If I didn't say calcium chloride and I just said like calcium chlorine, I'm talking about two separate elements. So if you're wondering why we changed the name of the anions on the periodic table, it's to tell us that they're in an ionic compound. All right, do I have a question? I can hear someone's mic, but maybe no question. I think I got one in the chat. Hold on. Oh, no questions. Okay. All right. This is difficult. Like I cannot tell you how much trouble this gave me when I was in university naming just, well, one, I had to memorize the polyatomic ions. That didn't help. But two, I just never understood it. And I think I really just needed to practice because it is easy once you get the hang of it. You just work with the metal first, then work with the non-metal. So unfortunately, guys, these examples are listed in order of like really easy to really hard, which means instead of doing like the first 4 and then you guys try the next 4, I'm going to have to do them kind of like every second one. So I'm going to do with you guys today A, C. I'm taking some easy ones. And then I'll do E and G. And that will, no, maybe I won't do G. I'll do E and F. And I'll leave you guys with some to practice. All right, so the easiest one. Some of you could probably name this one without having named something before because it's NaF. So NaCl, we've been talking about table salt for months or for weeks. That's sodium chloride. Well, this is fluorine. So this would be sodium fluoride. But I wouldn't really be doing my job if I stopped there. So let me kind of break this down. I'm going to draw a line between the metal and non-metal. I really want these to stay separate. So first thing I do, I name the metal. Now, if I've never, ever, ever named this before, or like I have no idea what I'm doing, your first step is to go to the periodic table and confirm the charge that sodium has. Okay, so I mean, I know that sodium is +1. I'm very confident in that. But if you're not sure, go to your periodic table and find sodium. So sodium right here. It's in group 1. Everything in group 1 is +1. So I go back to my notes here. This is just sodium. Now you might be thinking, why did you even look that up? Who cares what the charge is? We don't, the charge has nothing to do with this. But if this was a ion or element that had 2 or more charges, like cobalt, you'll see me do that in a minute, you need Roman numerals. But I don't need them here today for sodium. Now, the next thing I'll do is name F. F is not polyatomic. It's only one element. So I would call this technically it's fluorine, but sodium fluorine is not the name of a compound. Sodium fluorine is the name of two separate elements. So I need to change the ending and call it fluoride. And now when I read that aloud, so I'm talking to your lab instructor or even you, and I say, oh, can you pass me the sodium fluoride? You're looking for a compound or element that is sodium bonded to fluorine, not separate. All right, next one. Next one's a good one. I like the next one. It looks like an interesting compound, COO. It's C lowercase o, uppercase O. So this means I have cobalt. CO is cobalt. You guys used this in the lab this week. Cobalt was it should have been red. It turned a little purple over time as it absorbs water. But cobalt is, especially this one, cobalt 2 is red. I guess I just gave you the answer, didn't I? Oh, well. Next thing I do, I'm going to write the anion, oxygen. Now I don't say oxygen, so I wouldn't call this cobalt oxygen. I would call this cobalt oxide. But I'm missing one thing. I need to tell you guys the charge on the cobalt because it could be 1, it could be 2. Let's look. Let's go to the periodic table and see what are my options. All right, let me clean up some of the messy ink here. All right, so cobalt, number 27 on the periodic table. The options for cobalt are cobalt 2 and cobalt 3. All right, so now I have a 50-50 chance of getting this right. If you're doing this on a test and you have no idea what to write down, you technically have 50-50. There's two options. This could be cobalt 2 plus or cobalt 3 plus. So I'm going to ask you guys, which one of these should go with the oxygen that's 2 minus? You really
2 plus?
Exactly. Yep, I'm getting a few people say the answer. You really need to look at the formula though, guys. The formula, I have a 1-to-1 ratio. So 1 cobalt must cancel 1 oxygen. And as like 3 or 4 people said out loud, I'll check the chat now. Everybody in the chat is saying the same thing. It's 2. This will cancel this. I should have mentioned this on the other slide. All ionic compounds, all of them are neutral. So all of these compounds here, they can never have a charge on them. They always have to cancel. Okay, you guys seem like you're doing pretty good with this. It's 4 o'clock. Let me do 2 more, and that's it. We're done, and you guys can try these over the weekend if you're bored. Now, I'm picking some good ones here. I like these 2 examples. We're going to look at E and F, and then I'm going to ask you guys to try the rest. Okay, E has something special in it. I'm only showing you E because it does have a little difference in E. There is 1 polyatomic cation. Okay, there's only 1. Now, what I would do when I name these is first thing, I would separate them, meaning I would like identify, okay, which is the cation, which is the anion. Okay, so I just draw a little line there. And I know in E, for example, the first thing on the left in brackets, this is our cation. Cation always gets listed first. The second thing in the name is always the anion. So this is confusing because I got a polyatomic cation. So I'm going to go to my periodic table. I'm going to go all the way up. And I notice there are actually 2 polyatomic ions that are positive. And wink, wink, wink. You could see me winking here. There's really only one you'll ever need to know, and that's ammonium. I've never used mercury or asked someone about that mercury one. So ammonium is our exception. If you ever see NH4, it is a cation and it is a polyatomic ion as well. So I'll go back to this. This is ammonium. So ammonium, remember guys, with your polyatomic ions, do not touch the name. Do not change it to ammoniide or ammonate or not. Don't mess with the name. All right, my next element is just S. I know that S is not polyatomic, it's just sulfur. But I don't want to call this ammonium sulfur. I need to call this ammonium sulfide. Only the elements on the periodic table get changed to IDE. The polyatomic ones, don't touch them. And you'll see this in my next example, potassium bromate. K is potassium. Now notice, guys, in both of these, there are no Roman numerals because they only have one charge. Okay, I don't need to write the charge for potassium or ammonium because they are both only 1 plus. That's the only charge that they can be. So potassium is fine. Now, BrO3. Maybe you don't know what that is. That's cool. That's fine. Go to your data booklet, which keeps disappearing for me. Hold on, guys. Okay, sorry, go to your data booklet. I'll share my screen again. Sorry, I just gotta do something. Okay, go to your data booklet, go to your screen again, find bromate. They're in alphabetical order. So look for B and I'll find it right here. Oh, and sorry, I shouldn't say look for bromate or like because you don't know the name of it. I mean, if it starts with BRO, it's the name will probably start with a B. So these are all listed in alphabetical order. Like nitrate starts with an N. Sulfate starts with an S. What's a phosphate starts with a P. So when I see the polyatomic ion BrO3, it's probably going to start with a B. And sure enough, here it is, bromate. Not bromite. You'll lose a mark if you don't call it bromate. Okay, don't touch the name. This would be potassium bromate. So potassium, sorry, I just wanted to get my colors nice and organized. Bromate, there we go. Again, no Roman numerals. G, when you guys do this one, this will have Roman numerals. All right. And the reason G will have Roman numerals is because it's iron, and iron can be 3 or 2. So guys, that's it. I'm done. I know it was a quick class, but this is where I finished with my other students. So I'm going to hit stop record. And if you guys have any questions, let me know. Other than that, have a good weekend and stay safe. Wash your hands, wear a mask.